Okay, this is a review over roots and radicals. It's standard 1 of this semester. Now, the assessment's not this long, and we're not doing all the problems in one video, because a lot of them are just cookie cutter of the same thing. Okay, but it is one of the standards for some reason people have struggled with, and this year is no different, but it's to be expected. Maybe I'm not the greatest teacher at it, and that could very well be, okay? But, I kind of like to go over these just so we have this. So I'm going to just do a couple, maybe 1 to 2 on each page. You don't need to do the rest. I'm not. Okay, so what you need to do, these directions are screwed up. What you need to do is write that so it has an exponent. So you write a base 16. Now, if it's in a root or a radical, you're going to need a fraction on that. Okay, now in the root index is a 3, so that's on the bottom. And there's no exponent here. 16 is not to any power, so it automatically is to the 1. So 16 to the 1/3 power and the cubed root of 16 are the same thing. So let's take a look at this one. Okay. Then we'll move on. Okay, we have a 5 in the index, and we have a 18's to the 3rd power, so it's 18 to the power of 3/5. Now I do want to look at this one, okay. So if you don't have a D in the index, it's a 2, so it's 30, and then a 2, and then 4 over 2. Now technically 4 over 2 is 2, so it's really 30 to the 2nd, okay? But either one's okay as long as you understand that, okay? Okay, now we do need our root sheet to simplify the radicals, so we need to simplify this. Simplifying means use this sheet, okay? So multiplication has 3 steps, 1, 2, 3. Now, I'm going to put coefficients of 1 here. And step 1 is I multiply the outer factors, so that's 1. And I multiply the inner factors, 4 times 20, and that's 80. So we have the cubed root of 80. Okay, my next move then is to simplify the cubed root of 80. So it's a perfect cube. So I'm on this list here, and I want to see... what I want to see is what 80 will divide by from this list. Well, 80 divided by 64 is a decimal. Again, we don't go with numbers bigger than 80. That doesn't work. Decimal. 80 divided by 27 is a decimal. 80 divided by 8 is 10. Okay, so we found it. So I drop the 1 like it's hot, and then I make 2 cubed roots. And I just put those 2 factors, 8 and 10. Okay, now the reason we do this is because we always eliminate the first radical because that's equal to an integer, a whole number, 2. And then 1 times 2 is 2. So it's 2 with a cubed root of 10. Okay, next page. Now, that was how you multiply. Now you're adding. So adding's totally different, okay? You don't do 1, 2, 3. You don't add the outsides, add the insides. No, you can't add anything. You can't do anything until the numbers under the roots are the same. And I accomplish this by simplifying them separately on this table. So we have 5 with a cubed root of 120, and we have 6 with a cubed root of 405. Okay, so I start dividing, okay, from my list. So cubes, 120. Now, we'd start with 64. That didn't work. Now try 27. That didn't work. Now try 8. It's got to be 8 or we're in trouble. It does, okay? So I drop my factor of 5. And then times. It's still times even though it's plus. We don't plus anything till the end, okay? Now, so you got 8 and 15. You want to put the 8 first. The number from the list that I got goes first, and then the number I got second. Okay, so I get rid of this because the cubed root of 8 is 2. Now, why is it 2? Because what number times itself 3 times over is 8. It's 2. Okay, so 5 times 2 is 10. Don't add 5 and 2. People do that a lot. Okay, now next, I try to divide 405. So I'd start at 343. Nope. 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 You got to be patient. Don't come whining to me that you can't find it till you've got up to 1 at least. Okay, we got it. And what do you know? We got 15 again. That's good. So I dropped the factor of 6, and that's multiplied by these two factors I'm about to break up. And that's 27 and 15. Now, again, we need to replace the first radical with its equal of 3. And then 6 times 3 then is 18. So we have 18 with a cubed root of 15. Say, now what did that accomplish? Well, I got the common radical, radical 15. You don't add the 15s. You just take then 10 plus 18, and that's 28. Okay, and then this would be just more of the same because they're all adding. Okay, now you're still simplifying these. I'll pick this one. Okay. So this is a cubed root. Now with variables, we need to separate the coefficient from the variables, and I need to think about each variable, each factor in here independently. Some of you are like, do we have to factor on the standard? No, there wasn't a lot of factoring. I think there was one problem where you actually had to factor. So 137 on my list of perfect cubes, so 135, my bad. I'd start dividing at 64. That did not work. Divide by 27, that does work. So I rewrite this as the cubed root at 27 times the cubed root of 5. And this goes away, and that becomes 3. By the way, what you're trying to accomplish, you're trying to get as much of this expression out of the radical as you can. So a 3 goes outside, and a 5 goes inside. Okay, now this one's kind of weird. You have 2 x's, but you can't get a group of 3 because you're grouping them by whatever there's in the radicals index. So you can't get anything, okay? So you can't get a full group. So no x's go to the outside. X to the second just stays on the inside. Okay, now y to the 6. 1, 2, 3, 4, 5, 6. You group them by 3. So that's 2 groups. So y to the second outside. And no y's would remain inside because I was able to group all of my y's. 1, 2, 3, 4, 5, 6, 7. And I can get 2 full groups. So z to the second power's outside. Don't put 2z, it's z to the second. And then z inside. Because for every 3 z's, that's z to the third, but a cubed root cancels it out and gives me z. Same thing here. So that's basically 2 full z's and then a z left over. Okay, now we start solving equations, and I'm going to do, I'll do this one down here. Okay, I need to solve the equation. Now, I don't know how many answers x has when it's in a root like that. So what I need to do first is undo any operations taking place outside my root, if there's an outside the root, okay? So again, here's the root. I'm going to mark where that stop begins and ends, okay? It's because I don't want to worry about inside. I'm just looking outside. So first I have a minus 4. We're going to add 4, and that takes that side to 36. So I got 3x minus 2 equals 36. Now there's another operation out there. There's a multiplication by 3. So the way to get rid of a multiply by 3 is divide by 3. And that's 12. So 3x minus 2 equals 12. Okay, now it's time to get rid of the root. We get rid of a root with a second power. The opposite of a square root is a second power. And then we take our 12 to the second, which is relatively easy. It would be 144. It's not 24. So that's 3x minus 2, free of the root, equals 144. And then I add 2 to both sides. 3 times x equals 146. Divide by 3. You're going to get a decimal here. That's all right. 48.66, it's the same as, actually, if I wanted to be a real jerk, I'd make you write it as 48 2/3, but I'm not that mean, okay? Because 0.6 repeating is 2/3 as a fraction. Okay, now let's turn the page, and let's go with this bad boy right here. Now again, you have a root. Now, you don't have any operations outside of it, okay? So you're ready to do your second power to get rid of it. But this side here, I have a binomial to the second power. So this side I'll have 3x plus 52. But on this side, I'm going to have to take x plus 4 to the second. Well, that means I have blank x second plus blank x plus blank, okay? So I go to a piece of scratch paper, okay, and I think I gave you one, and I just simply duplicate and multiply two binomials, x plus, no, you're not using math, Papa, for this, okay? So it's 1, 2. So I take 1x times 1x, 1x times 4, 4 times 1x, and then 4 times 4. That's 1x to the second, that's 4x, that's 4x, and that's 16. So I combine like terms. So that's 1, that makes 8, and that makes 16. So I go fill out my trinomial with 1, 8, and 16. Now here's a problem I see a lot of people do. They take this to they try to factor this. No, you don't factor this. You got to move this crap over here with it. So I minus 3x from 8x, and I minus 52 from 16. Okay, so now I have 1x to the second plus 5x. 16 minus 52 is negative 36. Okay, and now you factor. You can't factor. Don't try to factor until you have the equation at 0. Okay, you don't have that, you're not ready to factor. So that's GCF and the T table. Okay, I didn't give you very much room. You're only going to need a little bit of space down there. GCF's 1, don't worry about it. 1 times negative 36 is negative 36, so you're trying to find a difference of 5, which is positive 5. And you can find that if you divide by 4, you get 9. Now, positive 5 means 9's positive, and the negative and the difference means the signs are opposite. Okay, my A is simply a 1, so that's just x minus 4, x plus 9, and I can see by now the equation's got 2 answers. Okay, when we have to square a binomial means you have to square a plus with 2 terms, or a minus, okay? Okay, and then you're going to get 4, and you are going to get negative 9. Okay, that's enough of that. Now go to this page. Now you see a power, okay? That's good. So when I see a power, I know how many answers there are. Now it's to the 3/4 power, okay? So you're like, well, what's up with that? Well, it's a fraction power, but that's okay. So I see that 3 right there. It's odd, because that's actually the power. It's odd, so there's only one answer, because that's the only power we have, so there's either one answer or 2 answers. Okay, and all we have to do is get the x to the 3/4 by itself. So first, I got to divide by the 6. You can't deal with the power until every other operation's been dealt with. And that's going to be 36. Then if it's a power, if it's a fraction, a rational exponent, that's what a fraction power is called. You don't do a root. You just reciprocate your fraction and you raise the other side to the power of the flipping, okay? So 4/3, 4/3. So I take 36 to the power of 4 over 3. That's going to be 118.87. That's kind of a weird answer, but that's okay. I just randomly made these up. Wasn't really worried what answer they gave me. Okay, I'm actually going to do this one then down here too. Okay, so I see my exponent's a 4. Okay, that's the only power that x is 2 in that whole equation. So I don't need any of that factoring nonsense. That's when you have another x that wouldn't be to the 4th, you'd have to factor. But it's even, so there's 2 answers, and then I undo the operation. Not hard. So that's 53. Now this time we have an integer exponent, so I make a root, and I put a 4 in the index, because I'm not finding the square root, I'm finding the 4th root. So I go 4 second caret, when it's not a square root, 53. So I could get 2.70, I'm going to round it, 2.70 or negative 2.70. And if your rounding's off, I don't care. Okay, and then I'm going to look at one on this page, okay? Okay, I see an exponent, Okay, but the problem is the exponent belongs to an entire binomial parentheses. Okay, so again, just like the last problem, 4 is even, so there'd be 2 answers, but I'm going to need to replace that and simplify the equation with my q. Okay, so I replace that with q. Then what we need to do is make our table. Okay, so x minus 6 is going to be brought back in over here on both sides because there's 2 answers. Okay, then I subtract 4, and that's 57. So I have a fraction, so I'm not in a good position to do a radical, so I reverse the fraction, take it to the power of the reciprocal, and it's to the power, not times 3/4. 57 to the power of 3/4 is 20.74. So you could go positive or negative. Okay, then you just add 6 to both sides. That's 26.74. And then you add 6 to both sides. And negative 20 plus 6 is negative 14 with a 0.74. Yeah, I think that's right. Okay, and then this would be more of the same. You'd use the actual root there. Okay. Remember, if the power up there is odd, you're only going to use one side. Okay, because you only need one answer. The other answer is not there. Okay, rationalizing expressions. Okay, this is pretty easy. I'll just do a couple. So we got 2 whole numbers here, 2 here with a minus and a plus, so we need to do the FOIL. First, outer, inner, negative 4i, remember. And I know this pencil's hard to see. And last, negative 4i times positive 4i. These are called conjugates because they're the same thing. You just have a positive, a plus, and a minus. So that's 36, and that's 24i, and that's negative 24i. Those cancel. Yeah, that always happens when you multiply 2 conjugates. Negative 16i to the second, which holds a special value of negative 1. But then you times negative 16 by negative 1, and that's 16. Okay, then you combine like terms by adding, and that's 52. Quit multiplying those. The multiplying's done at that. Okay, now down here, this is an easy one. Okay, it's just a 1 multiplication. 7 times 1 is 7 with I to the second. Well, that's negative 1, and 7 times negative 1 is negative 7. Okay, we don't need to do the rest of those. Okay, now multiplying radicals, you want to make sure each radical has a coefficient. That's the way I like to do it. Okay, Coach Larson doesn't really do it that way, and that's fine. That's cool. Okay, if he has his own way, then that works for him. That's fine. I like to put numbers in front. Okay, I'm just warning you. If you're in trig, he's probably not going to do that. If you like his way, that's cool. I understand. If you just remember, if you put numbers in front, if that helps, do it. Okay. So I take 4 times 1, that's 4, and then I multiply the square roots, open up a square root, and we need to take 2 times 2, which is 4. Now, the square root of 4, you can't leave it like this, because the square root of 4 has a number. It's 2, so 4 times 2 is 8. Okay, now here I see addition and subtraction operators, so again, I want to put 1s there, and this becomes a FOIL. Okay, it's the same way you would do a FOIL, 4 times 4 and 4 times negative 1 square root of 2, and then 1 square root of 2 times 4. And then 1 times negative 1, remember to connect the square root of 2's on. Okay, so that's 16. That'd be negative 4, open up a square root, and you just have 2. 1 times 4 is 4. Open up a square root, you have 2. Well, those can cancel because they're just opposites. 1 times negative 1 is negative 1. You have to open up the square root and take your 2 times 2. That's 4. And the reason I'm having you do these, you will see if you take trig. Okay, negative 1 times 2 is negative 2, and then I add, and that's 14. You should end up with just one single integer at the end of the problem through all that crap. Okay, I'm going to do one graph. Okay, now this is different. There's no asymptote to this. There's no exponent. Okay, so forget that. But what we do have is x being inside of a square root. So obviously the most logical thing would be to only pick perfect squares. Okay, so that's why I go with 1, 4, 9. And I could keep going. I could go 16, 25. And then I include the negatives just in case, because some of these, yeah, you'll see what I'm saying as I get to it. Now, one thing, before I even plug in, now unlike the exponential functions where you had a power, your x was a power, and you got rid of the operation with the x, but you did that after everything was calculated. Well, when you do a square root, you need to undo that before everything's calculated. So how would I undo a minus 5? The opposite. You don't minus 5. You do the opposite, which is plus 5. You minus 5, you're going to have a whole lot of problems. So that's 14. See, because now 14 minus 5 is 9. 9's a perfect square. Okay, had I minus 5, I would have gotten 4. 4 minus 5 is negative 1, which the square root of a negative is not even possible without doing the I, which you can't graph with that. Okay, so then I add 5. That's going to be 9. 9 minus 5 is 4. Good. Okay, and then I add 5. That's 6. 6 minus 5 is 1. Add 5. 5. 5 minus 5 is 0. Add 5 to that. That's going to be 4. Now 4 minus 5 is negative. That's gonna, you'll see what happens. 1 and negative 4. Okay, and also another thing you do on a radical, there's domain restrictions here. Okay, you need to mark the middle point where you started with 0. Okay, now these are the numbers we punch in. Now, I'm just going to give you square roots from here on out. So you go 2 second x squared, and then 14 minus 5. Then you need to close a parentheses so the square root ends, and then plus 6. You got 12. And the nice thing about these is they do follow a pattern. Okay. Then I replace 14 to, you just delete the 4, put a 9 over the 1, 10. Okay. Then I take 6, 8. Remember, these can be done in your head, too. For like 9. 9 minus 5 is 4. Square root of 4, 2. Times 2 is 4. Plus 6 is 10. Okay, and then this one I replace with 5. If you're not good at doing those operations in your head, then you need to use a calculator. Okay, nothing wrong with that. Okay, now I'm going to put 4 in. Domain error. Well, no crap, because 4 minus 5 is a negative. You can't have negatives in a square root without the I. Well, you can't put I's on a graph. Okay, so cross those out. Now, you need to graph this one first. That needs to be your first graph because you stop. Okay, that's your cutoff point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Stop. Okay. 6, 8. Why did I do that? I have to go by 2s. That was stupid. Okay. I have to go by 2s on both lines. Okay. So 5, 6. 1, 2, 3, 2, 4, 5. 2, 4, 6. Okay. Stop. Okay. So 6, 8. 2, 4, 6, 8. Who do we appreciate? No, 2, 4, 6. 2, 4, 6, 8. Who do we appreciate? Not me after I'm screwing up on this. 9, 10. So 2, 4, 6, 8, 9, up 2, 4, 6, 8, 10. Keep connecting. Okay, 14, 12. 2, 4, 6, 8, 10, 12, 14, up 2, 4, 6, 8, 10, 12. Now the arrow goes this way because you could keep plugging in up that way because you could have 1, 4, 9. You could have also done 16, 25, 36. It goes on infinitely that way. But stop. I don't want to see an arrow there.